Hello, friends, students, colleagues, and C++ learners. Today I'm going to talk about a self-referencing this pointer that is available to all C++ classes. Once an object is created, a pointer to it called this is available inside the class, and we'll talk about that, how we can use that. And then a little bit more about default constructor and destructor and copy constructor again, although I've done a whole entire video on that separate one, but I'll describe them more in terms of this pointer. Okay, once again, this is Dr. Satish Singhal, PhD. I'm a professor of computer information technology at Rose State College in Midwest City, Oklahoma. Okay, so basically this is a pointer to itself. In all C++ classes, struct and union objects, there is automatically a pointer that stores the address of that object that has been created. And name of this object is very simply THIS this. And this pointer is only available inside non-static methods, constructors and destructors. It is not available inside static methods, static functions, because static functions are created as soon as, even before any class object is created by constructor call. Okay, in any case, you know that static members are property of the entire class, not the property of an individual class object. So this pointer is not available to static functions, only available to non-static functions. So we are going to design a simple class foo and print address of its object using this pointer. So first I want to give you a little bit of an idea of the class. So this is class foo. Inside the class I have public. This is the default constructor that I'm writing. And basically this is very important to know that once this left curly brace is crossed, right after that there is a pointer called this that stores this object that will be created by the time this constructor ends. So as soon as this brace is crossed, this pointer is created, pointer to this object is created, and it can be used inside the constructor and any other function that is part of this class, but function must be non-static, cannot be static. Okay, so after the completion of constructor call, this pointer is available as if it is a hidden class data member to any non-static member function. So here I'm trying to print this address of this object itself right here, and so if it's a pointer to this object, then it stores the address of the object, and casting it to long type simply is to avoid hexadecimal numbers being printed. Okay, so let's look at this one in Xcode. So here's the Xcode, here's the class foo, here's the constructor. So basically, as soon as I cross this left curly brace of the constructor, this pointer is born and I can actually print the address. Okay, so of course anything that is created has to be destroyed. So I have a destructor also here, but let me just run this and show you that constructor, this is print statement, the constructor is printing the address. Okay, so this is our output. I'm gonna just start a Microsoft Word document to show you a more expanded version of this. So I can just do. So notice that the address of the object that was created is right here. It's a long number, don't need to really worry about it, but it's there. Anything that is created is destroyed also. I have a little code in Destructor that gives me the same thing. Okay? Same address. Okay, so let's go back to PowerPoint. If I create 3 objects, with the foo, and this is the constructor, let's say I create 3 objects, F1, F2, F3. So schematically, this pointer is created for each one of them. So if this is F1 and hypothetically speaking address of F1 is 1000, then this pointer is storing that 1000 and pointing to that. If hypothetically F2 in the main is created using the constructor call and address is 2000, and this pointer for F2 is creating that address. And if I create F3, it's creating this pointer for that separately, and this pointer is storing address of that. And we can do that in the main. So let's create 3 objects, and then it's going to print the address of all 3. Earlier code was that, but now I'm going to change it to F1, comma, F2, comma, F3. So in the main function, I'm creating 3 objects. Okay. So I should have address printed 3 times. Okay. Notice I can't put identity of each one inside the constructor unless I pass it a string or something, which I'm not going to do right now. Okay, so let's run this one where I've created the 3 objects. And this time I will see, I'm going to take this and pass this to Microsoft Word. Sorry. So 3 objects have been created. Address for first one is this, second one is this, and third one is this. Operating system does not guarantee you contiguous RAM, but these 2 are pretty contiguous. This one is at the different address. So we created 3 objects. We can print address of each one of them because my constructor is able to use the pointer to that object, and I can print the address. Okay. And schematically, this slide shows that also, which I just showed you in the Xcode. Okay, for now I'm going to show you a trivial use of this pointer, and more sophisticated use will be shown when we discuss classes that have pointer data member. So next slide shows how constructor, destructor, and member functions can use this pointer for member selection. So let's say I have class student, and it has 2 private data members, string type name, double GPA. Then I can actually write a constructor with this kind of syntax, that string name not set, that's the default argument, double GP equal to 0. Then inside the class I can identify this class data member using this arrow name and set that equal to nm, this argument. and I can identify GPA as this arrow GPA equal to GP, set this GPA to GP. So if you use this pointer inside the non-static methods functions to identify class members, not just data member, you can use this with functions also. That's called fully qualified name of a class member. So let me say this again. Fully qualified name of any class member, any non-static, so to speak, any non-static class member is this pointer arrow name of the member. So fully qualified name of the class data member name is this arrow name. Fully qualified name of GPA is this arrow GPA. And you can write an alternate code, although it's a bit of a hassle. Alternate code for this arrow name will be asterisk this parenthesis dot name and set it to nm. So alternate code for that will be this. And alternate code for this arrow GPA will be asterisk this parenthesis dot GPA equal to GP. And of course, since this is a pointer to the object itself, it can be used for member selection. We showed that how you can use a pointer to objects for member selection. Remember, we did the pointer to a string, and we had that pointer arrow, the length function was called. Okay. So that's the trivial use inside the constructor. But there's another use we can make, and since I'm not showing any output, I'm not going to type student class into the Xcode. You can if you want to, and a copy of this PowerPoint will be available to my students. So the other use of this pointer is facilitating name economy. When constructors are large and they take a lot of arguments, programmers get tired of finding name of the constructor arguments. Since fully qualified name will be available for all the class data members, we could make the argument exactly the same as the class data member. So here, see, this name has the same spelling as this one, and GP has the same spelling as this one. But then in order to set class member name equal to this, we're going to have to use the fully qualified name. So this arrow name equal to name, now that differentiates between the two. This arrow name will always refer to this, and of course local variables have precedence, so name alone will be referring to the argument that's being passed. And same thing, this arrow GPA is really referring to this one because this is the fully qualified name of that, and this GPA is the argument being passed. And of course alternate code for these two lines can also be that asterisk this dot name equal to name and asterisk this dot GPA equal to GPA. Okay. So this allows name economy because I don't have to invent new names. I can use the same name for the arguments as they are the class data member. But since I'm identifying class data members with fully qualified name, the name on left hand side becomes different from that. This is the argument, this is the class data member. This is the argument being passed, this is the class data member. Okay. There is one caution, of course, in name economy, and I generally never use it. And that is, the client should not really know what the names of your class data members are. Okay. So name economy could violate the principle of information hiding unless you make your constructor private and use get instance and things like that. It could violate the principle of information hiding. Unless you expose to the client only the data type of the constructor. Okay. The other thing is, other caution you have to practice is that if you write the code like this one, student string name, these are the default argument, double GPA, and then you write code like this, the name equal to name, GPA equal to GPA. Well, this constructor does absolutely nothing whatsoever, because this name actually shadows the class level variable called name. So we had this one. So if I remove this pointer from here and say name equal to name, as I'm doing here, well, this no longer refers to the class level variable, because local variables have preference, they shadow the class level. So in this statement you are setting this variable equal to itself. This is not the class level. This one and this one are the same thing, which is this one. And if you say this one, and this one are the same thing. So in this one you are doing nothing with the class level variable. So if you're going to use the same name for the constructor argument, then the one class level one has to be fully qualified the way we have done it here. This code is totally worthless, useless, it has no purpose whatsoever. Okay, because this one shadows the class level variable name. So any use of name only refers to this constructor parameter, and GPA shadows the class level variable GPA, and in this code class level variables are not initialized. So personally I don't like to use same name, because first, one thing, you could end up giving away your class level variable names and information hiding is lost. And second is, if you do accidentally this, then your constructor is totally worthless. Okay. Okay. Since this is a pointer to current object, dereference value of this is the object itself. So asterisk this is the alias for that object, and that makes sense actually, because if it's a pointer to the object, dereferencing that is the object itself. Okay. Now we talked about destructor in another video, but let's touch on them again. Constructors construct object for class, struct and union. Destructors deconstruct and dispose the object created by the constructors when object go out of scope. Just like every class is provided with a default constructor, even if you don't write one, every class is also provided a default destructor. Destructors are invoked automatically. They are never invoked in the client code by an explicit call. Okay, that could create a huge problem. And syntax for writing destructor is that destructors are written following tilde and by the class name. Tilde followed by the class name. So for the class foo, destructor code would look like that. The tilde foo parentheses and then code for the destructor body. Just like constructors, destructors also must be public member, and next slide showed it more formally. So I'm going to write the constructor for foo, and I can print the address of the destructed object also. So okay, sorry, this is the constructor and this is the destructor. So tilde foo, and see how destroying the object of this address, and then I cast it to long type. So this code will be automatically invoked when the object goes out of the scope. So these are some of the properties of the destructor. It is, if you provide an explicit destructor, it's going to have following properties. Starts with the tilde, following by the class name, has public access, is invoked automatically, no explicit invocation in client code is needed. Destructors cannot take any argument, constructors can. Constructors can be overloaded, but destructor cannot be overloaded. There can only be one destructor per class. You cannot overload a destructor because they're not allowed to take any arguments. Constructor can be more than one, overloaded, can take argument, destructor cannot. When do we need an explicitly written destructor? Every class should have virtual destructor. Deviating from that, you may not need explicit destructor if class does not have a pointer data member whose pointees are dynamically allocated memory in the constructor. However, all classes that have pointer data member in which memory is allocated in constructor, they require a destructor, otherwise memory leak will take place. Okay, so I'm going to contrast action of constructor and destructor right here. So in the class foo, I have a constructor here and I have a destructor here. Constructor prints the address of the constructed object. Destructor here is printing the address of the destroyed object. And again, this is optional, you don't have to put it in, and I just put it in. And in the main function, then I have these three objects. Picture of them in the RAM will be this, that F1 is here and its pointer, F2 here is pointer, F3 here is pointer, which is this pointer. And if I do this, address of 3 will be printed, and then from the constructor call, and also there will be 3 in the destructor call. It'll be better to look at it in the Xcode. So let me go to Xcode and show it to you a little bit better there. Okay, so let me unfold the code for the destructor. So here's the constructor which prints the address of the constructed object. Again, as I said, this is optional, you don't have to put it in. And this is the destructor, and the only code right now is just printing the address of the destroyed object. So if I run this, I get this output, and we can see it better in the Microsoft Word. So notice I'm going to highlight the addresses from the constructor call. So this is the address of the first object created by the constructor call, and see which one does it match with. This one matches with this one. Okay, and then second object, which was F2, this one matches with this one. Okay, and the third object was F3, and this one matches with this one. Well, all of a sudden we have learned a very important fact. The destruction is exactly in the opposite order of construction. The one constructed first is destroyed last. One constructed last is destroyed first, and then order is in between. Okay, so destruction takes place in exact opposite order of the construction. This has to do because these variables are being created on the stack. The stack has a property last in, first out. So this constructed object was on the top of the stack. So when destruction takes place, the stack is removed, the stack is popped, so that one goes first. So this is a very important fact which you must remember, the order of construction destruction. Destruction takes place in exact opposite order of the construction. The one destroyed first is the one that was created the last. That's the property of a data structure called stack. Okay. And this is in the PowerPoint the same thing. Constructor prints the address of the three objects F1 and F2 created. Destructor then does the destruction in exact opposite order. The last one created is destroyed first, middle one, and the one that was constructed first is destroyed the last. Destruction is done in exact reverse order of the construction. And once this call and main function is completed, then picture in the RAM is blank because everything has been destroyed. Okay, let's talk about the copy constructor. When a class data member is passed to a function by value, the copy of object must be made and passed to the function. Same mechanism takes place when a function returns a class object as a return value. Local object in the function is destroyed, so its copy is made and returned to the caller function. These copies are made by a default copy constructor provided to all C++ classes. And we'll hypothesize how copy constructor will look like and prove its existence. And I've done that in another video. And in class 4, we say that copy constructor will be as follows. Since it's a constructor is going to have same name as class, it is going to take an argument of foo type, and to copy the object passed, it'll just do that dereference value of this is equal to obj. So basically it's saying that whatever is in this object, copy into the current object. And then we have this output statement. This is a default assignment operator that's also available to all the C++ classes. Okay. And I'm going to show this to you in the XCode. Let's go to XCode. So I unfold the code for the copy constructor. So copy constructor will take an argument of the same type, and meaning of this statement is that copy into the current object the object that has been passed here. Okay. Copy constructor is also called implicitly when you pass a class object by value to a function, or when you return a class object from a function. They're called implicitly. You should not, and a lot of people violate this rule, you should not call copy constructor explicitly. They are called implicitly automatically. People do that to make copy of objects, but that's a bit silly. I think you should do that with assignment operator, not with the copy constructor. Okay. All right. However, I cannot show you how the copy constructor works unless I pass foo to a function by value and return it from a function by value. Let me first show that to you in the PowerPoint, and then I'll put the code in here to show it to you here as well. Okay. So this is the code that we just saw in XCode. Constructor, destructor, and the copy constructor. Okay, we write two functions, foo bar that takes foo by value. So if we do that, it gets a copy of foo from the caller function, and then copy constructor will be invoked at that time. And I can put this statement inside the function foo bar that'll print the address of foo. Okay? Purpose of printing the address of foo will be that we can prove that address of the object that was passed from the main function is different from this address because copy has been made. And this one is returning foo. So a copy constructor will be invoked in that also. So this function returns local f to the caller function. Since local f will be destroyed, before destruction a copy is made and returned to the caller function. And in that case also copy constructor is invoked. So if I create an object f4 and call the function foobar, the schematic output is this. First we'll print the address of the foo type object, and then copy constructor is invoked, and the local object address is printed, which is different, and then of course there is destructor call. Okay. I'll come back to this slide, but let me just do this inside the Xcode to show the mechanism, and allow me to copy these two functions into my Xcode. And let's just do that after the class foo, before the main. There you go. Okay, so I think I'm having some trouble with this code, so I'm going to fix that. And this. There you go. Now it's fixed. So, purpose of this is done. So I'm going to comment that out. I'm going to create another object foo f, and using the foobar function, I'm going to pass f to foobar. Actually, let's make this different. Actually, there's f1, so that you don't think that I'm passing this one to that as is. Okay, local foo object. I'll just call it f1 because this one I know the name. Okay, so let's call the foobar function. Pass the f. Okay, so I said that when this function is called, since I'm passing by value, a copy of this has to be made into this, and then copy constructor is invoked. And this is my copy constructor here. So I should say before, first I should see, actually I should see three outputs. Four output. When I'm making this call, the constructor is being called. I'm sorry, not here. Okay, let's fold this one. When I'm making this call, the constructor is invoked, so I should get one output from the constructor. When I'm calling this function call to the foobar, then this is being copied into this. So I should see a call from the copy constructor. But this is being created also, so there should be another call from the constructor as well. And then when the function ends, this has to be destroyed. This has to be destroyed. So I'll see two destructor call as well. Okay, so let's run this code. Okay. Okay, so this is the address of this guy over here that I created. Then I'm making the function called foobar. And then I'm getting this copy ctor, from copy ctor. There we didn't print any address. Let's see the code. Yeah, it always only says from copy ctor, so we got that. So that means that copy constructor has been called. Then I'm making the function call foobar f. So in that case, that function prints address of local object f1 in foobar is this. So I'm getting that printed here. Okay. Then this has to be destroyed, and this got destroyed here by the destructor call. All right. No, sorry, not this one. Okay, it's that one here. It was created first, so we're gonna get destroyed last. But there's another destructor call, this one in between. Okay. So, and that matches with this one. See? And that's because this F1 here, into which copy was made, has to be destroyed also. Okay. Well, that copy is made by using an assignment operator, so you don't see a corresponding constructor call for that. All right. You only see a destructor call for that. In fact, if I put an assignment operator, more than likely you'd see that. Okay. So for that you only see a destructor call. But it was there because we got this output from the foobar function. Okay. So once again, whatever is created is destroyed. All right. So that's one way in which copy constructor is automatically invoked. Right there. When objects are passed to functions with by value, and return is the same thing. If I return a function, if I return a foo from a function, same thing. This will be destroyed after function call is complete. So before it is destroyed, a copy is made by copy constructor and returned to the caller function. We've shown this in another video, so we won't go into too much detail of that here. All right. However, I'll explain that in the video, in the PowerPoint. So if I have a function return foo, where foo is created and being returned, its functioning will be like this. That we can print in the main function the return address of the return object, and typically it will look like this, that you'll see the call to constructor, destructor, and we can print the address of the object also, and that has to be destroyed also. Okay. In fact, we could do this. Well, let's go to XCode and actually do it. So what do I need here? I just need this function. Actually, I already have it. Okay, I just have to call it. Okay, sorry about that. So let's remove this one. And since I have to give you a copy of this, I will just remove that. But actually, I'll remove that too. Let's do another one. Foo f1 equals, or let's say f4 equals return foo. So let's see what we get this time. Okay, let's see. This time I'm not getting the call from the copy constructor, although I should have. Okay, yeah, that's because, okay, I understand that. That's because only assignment operator is invoked this time. All right, so let's try to do it a different way. 4 equals that. Okay. Yeah, I thought this will call the copy constructor. In this case, it's not. Okay, we can do it this way. Let's take this out of here, but do this as an argument. And we have done that in the other video. And in that case, I'll just do a 4 here. Hold on a second. Yeah, okay, let's try that. There you go. This time we get a call from the copy constructor. In fact, two of them. Okay. I have two calls from the copy constructor because I'm passing by value and then returning it. Okay. And let's walk through it through the debugging process. So let me put it here, pointer here. Okay. And just run it now. Okay. So if I step into that, it's going to go to the constructor. So that's not necessary. I'm going to step over this one. So it printed the address of that object through the constructor call. Then step into. Notice we went into the copy constructor because the simple fact is that when I'm passing this to the return foo, a copy of this has to be made into that. All right. Okay. Keep going. And we got that output from copy C2. Now, copy of the returned object has to be made into this one. So I jump to the copy constructor again for that. And I get the second output that from copy C2. So that is done now. Copying is complete. And now the destructor calls. Now I get all these destructor calls. All the objects that were created are now destroyed. Explicitly, we see only two. The other two are also destroyed. Those are the local variable that were destroyed actually. Okay. All right. I think I'm going to just stop here. So in summary, this pointer is passed to all the non-static member functions in C++ classes, which can be used inside them for member selection. Fully qualified fully qualified name of every member is this arrow, the member name inside the non-static function. Thank you. I will talk to you soon in other videos.